Dear student, welcome in the CEC Gurukul lecture. We are discussing the electronic circuits in the physics. So, today's topic is related to the printed circuit board, that is the PCB, that is most commonly used just to prepare the electronic devices. So, in today's lecture we discuss what is the PCB and what material we use in construction of the PCB and what type of PCB are there. So, we discuss these points in today's lecture. First, what is the PCB? PCB basically it is a printed circuit board. How we print this board? This is a electronic board that connects circuit components on it. We have a board on which we connect the electronic component on that board. So it is known as a printed circuit board. PCB populated with the electronic components in a printed circuit assembly. And the PCB are rugged, inexpensive and can be highly reliable for the connection of the electronic circuits on it. It is we can do the mass manufacturing of this PCB and it is very professional. We use in most of the electronic gadgets. So what is a printed circuit board? A printed circuit board is a rigid structure that contains the electrical circuitry made up of embedded metal surfaces, which is called the traces, and a larger area of the metal that is called the planes. So, printed circuit board made up of the various traces as well as the planes which connects the metal surface with the basic electronic gadgets, circuits or the components. Components are soldered to the board onto the metal pads which are connected to the board circuitry. We use the metal boards to connect the electronic components on that board and that component is soldered. And that component is soldered on that circuitry board through the pads. This allows components to be interconnected, and through this pad all the components in the printed circuit board are connected, and this allows components to be interconnected. A board can be composed of one or more or multiple layers of the circuitry or we can have the large number of the components that connect on that printed circuit board and that will be used for the electronic circuit. Now circuit boards are built with the dielectric core material with the poor electric conducting properties to ensure the pure circuitry transmission and interspace with extra layers of the metal and dielectrics as needed. We prepare the circuit board by using the dielectric materials so that we can prepare a good circuitry that can transmit, that can be interconnected in a good manner. So layer by layer extra layers of the metals and dielectrics are needed in preparation of this circuit board. Now, the standard electric materials used for the circuit board is a flame resistance composite of woven fiberglass cloth and the epoxy resins that we will use. And for this we use FR4 with the metal traces and the planes of the circuitry are used composed of the copper. Most of the time we use the copper that will be used to prepare the printed circuitry board. Now, what is the material in the PCB? Conducting layers are typically made of thin copper foils. Means we use the copper foil to prepare the PCB material, or the copper will be used for the PCB. Now the board is typically coated with the solder mask that is green in color. You have seen that most of the circuitry that will be in the green in color, and that there are the copper thin copper layer that connects all the wires on this PCB, this printed circuitry board. Now other colors and that are normally available are the blue and red in this PCB. So unwanted copper is removed from the substrate after etching, leaving only the desired copper traces or the pathway. Basically we use the copper to prepare the pathway or to prepare the connection between the various electronic components on the PCB. So connect it through the copper traces. Extra copper traces will be removed through the through the etching process by leaving the desired copper traces or the pathway that connects the electronic components on the PCB. What are the type of material used for the PCB? Then there are three major type of material used for the fabrication of PCBs. Number one is FR4. That FR4 is the most commonly used material in the PCB. Then it is glass reinforced epoxy laminated sheet. That epoxy used flame to retardant and water resistance so that it cannot be damaged. It provides a good strength to the weight ratios. The tensile strength offered by this material is very high. So FR4 is commonly used to prepare the PCB. So next is the Teflon. Teflon is also important in preparation of the PCB. A kind of plastic material that does not provide any resistance, thus is used for the high speed, high frequency application. So from this slide we can know that Teflon is used to get the high speed and high frequency application, and PTFE, that is a Teflon, is extremely flexible, making it invaluable in the application with tight tolerance. Now it is extremely lightweighted, allowed it to use across the various industries. It is also flame resistance, exhibits high physical strength and provides the temperature stability, and is versatile in many applications. So Teflon having many applications, so that's why it is used in the preparation of the PCB. In most of the various industries where we need the flame resistance, exhibit high physical strength and provide the temperature stability, so Teflon then will be used for the preparation or the fabrication of the PCB. Now the metal is the traditional metal, that is the copper, that is used for preparation of the PCB. Aluminium, iron and extra others still used in preparation of the PCB. These materials allow use of surface mount technology for integration of the components. This technology basically used to integrate the components in the PCB. So this is used for the traces of the electronic devices or the and its connection through the surface mount technology. And then the mostly common material is used the copper, aluminum and iron, and they also provide the mechanical durability. Thus this material is used, and the product life of this metal based PCB is much longer as compared to the other material. So three materials we use in the fabrication of the PCB. One is FR4, second is the Teflon, and third is the metal. These three materials used for the fabrication of PCB, and all are having their own application, and according to the need we prepare the PCB by using the particular material. Now what are the parts of the PCB board? The commonly used board are having the copper traces on the surface and are known as the single layer board. So when we have the single layer, then we have the copper traces on it. Then the commonly used boards are having the copper traces on the surface and are known as the single layer board when we have the copper traces on that board. In a single layer board, there is a outer and inner layer that exist. On this layer where the copper traces are done, there is an outer and internal layer that exists. The main part of the PCB are explained here with the help of the perform the multimeter testing on the board. Now you see on the screen, these are the various parts of the PCB board, and these are connected that we can see through the multimeter. So these are the PCB parts: salt mask, silk layer, trace, pad, copper and other parts also. This is a picture of the PCB board. You see that it is a green color, and the mark various electronic components are connected through these traces on this board. So here the parts we will discuss, the various parts. First is the substrate, second is the copper layer, third is the solder marks, silk screen components, pads, traces, wires, top metal layer, bottom metal layer. These are basically the parts of the PCB. We define one by one. What is a substrate? Substrate basically the baseboard that can create through the use of FR4 metallic and ceramic material. That is a baseboard. That is substrate means we are having the baseboard on which the various components are connected. So that board is made up of the FR4 metallic and the ceramic materials. And these are a great feature. This material have a great feature and in the longer time in winter, and different from the thickness on the bases is used. The base is used basically according to the requirement, and the thickness is decided what the PCB is going to be fabricated. Next is the less cost board, and that is the from the PCB way we can have a high quality PR4 material also to prepare this PCB board. The substrate is one of the important layer, that is a basic layer for the fabrication of the PCB. Next layer is the copper layer. Copper layer is consists of the copper foil that has eliminated on the board through the adhesive reaction. So that it exists for both the side of the double layer and on one side of the single layer, so that can be connected. The other parts of the electronic components can be connected through this copper layer. Two layer, the board explained there are the two layers exist in the structure. So on the basis of the type of PCB, the copper layer are connected in the circuit. What is a solder mask? The PCB color commonly green, and due to this solder mask, but it can be of the other color. This layer helps to give the insulation to the copper traces by avoiding them to make the contact with the metallic and soldering. So solder is that helps to give the insulation to the copper traces, and it avoids the contact of the metallic or the soldering. So soldering mask is very important in the PCB. Protect copper traces on the outer layer from the corrosion. That solder mask, an area that should not be soldered may be covered with the polymer resist solder mask coating, and designed to keep the solder only in a certain areas so that it can be done accordingly. So now it prevents solder from the binding between the conductors, and there can create the short circuit. Next is the silk screen, and this silk screen is a white color silk screen layer that is applied to the upper part of the solder mask, where different letters, symbolic representation, numbers are written, and that is used to connect the component. Through silk screen, various letters, various masks, various symbols are masked on the PCB, so that it can be easy to connect all the components, electronic components. Silk screen of any color can be used, but mostly it is used for the black, red and yellow, just to mark the points or just to mark the name of the component or the numbering on the PCB board. So printing on the solder mask to design the component location, so that the component where this component is located and where that component can be located, that will be marked through the silk screen. Readable information about the component part numbers and the placement can be done through this silk screens. Helpful in assembling, the testing and servicing the circuit board, that will be helpful through the silk screen. Next is the component. What are the components we use in the PCB? So what are the components we use? Components are the actual devices used in the circuit. This includes the input and output connection. The components are known which includes the input and output connection in the circuit, and input output ports including power supply connections are also important in the PCB. In the PCB, components are the basic input and output devices. That components are the actual device used in the circuit, and that are the input and output ports. That includes a power supply, other connection also in the PCB board. Next is the pad, location that components connect to, that is the port where we can locate the components where it can be connected. So one can solder the components to the pads on the PCB. That pad connects the traces. So pads have a inner diameter and the outer diameter. Through this pad all the traces are connected. Next is traces. What are the traces? Traces connect the pads together. Traces are essential for wiring the PCB. Through traces, all the components on the PCB are connected that through the wire, equivalent to the wire for the conducting signals. So traces sometimes connect to wires. Wires and high current traces should be wide. So signal traces usually narrowed than power or the ground traces. So what are the wires? Wires are the pad with the plate holes connected traces and one layer of the board to the another layer. Attempt to minimum wire use in the PCB. Some component leads can be used by the wires. So what are the top layer in the PCB? The most of the component reside on the top layer. So you see on the screen, sometimes we use the top layer, and that top layer contains the most of the components on that top layer. So fewer traces on the top layer are done. So because most of the components are on that, so traces are less in this top layer. So components are soldered to the pads on the top layer of the PCB. Through the pad it can be connected. So higher circuit density are there in the top metal layer. Next is the bottom metal layer. It has a few components on this layer, bottom, and many traces on this layer. That is on the surface, and most soldering done on this layer. So this you are seeing that the layer, most of the layers are connected on the bottom metal layer. The wiring are there on that bottom metal layer. What are the physical design issues in this PCB? First issue is the component size, second is the heat dissipation, third is the input and output, and fourth is the mounting point. So there are some physical design issue in the PCB designing. First is the component size, second is the heat dissipation, input and output, mounting points. So one by one we will discuss. First is the component size. So make sure that the components will actually fit on that PCB board. So first we select what component we are going to be connect on that PCB board, and how much size we require to prepare this PCB board, and how many components are connected in this PCB board. So we have to make sure the components will actually fit on this PCB board. This especially applies for circuit that require the high component density. So we require the bigger size of PCB board. Some components come in the multiple size, like SMT versus through hole. So that will be also keep in mind just preparation of the PCB. And sometimes we can get the tall and narrow caps or the short and wide capacitor in the designing of PCB. The next point that keep in mind, that is the heat dissipation or heat sinks in preparation of the PCB designing. So heat sink dissipates heat of the component and does not remove the heat, just move it, and some components may get hot. So make sure that a large enough heat sink is required in this PCB. So data sheets, especially the size of the heat sinks, and so that the heat dissipation, heat off of the component is not done there. So a short circuit may result when the two devices share the same heat sink. Next and most important is the mounting point. So when we design a PCB, then we need a mechanical secure to something like that, that the PCB mechanically first that what are connected at what point. So could be the chassis consist of the metal frame on which the circuit boards and the other electronic components are mounted. So it must be the in that connection, and could be another PCB socket on the PCB and could be attached to the heat sink in that case. What are the parasitics? And there is a high frequency circuit, series inductance, shunt capacitance, and inductive coupling and capacitive coupling. These are the some parasitics are in the PCB circuit. So what are the series inductance? Series inductance for a low circuits, that must be less than 10 megahertz. The inductance of the trace may be significant in this PCB. The power connections, a shunt capacitor is added to count the series inductance for a long traces. In the series inductance, a capacitor has a low AC impedance source. So, a 100 nanofarad capacitor is often used along with the larger capacitor. So, ceramics have a very low impedance at high frequency. So, ceramics are used. Next is the shunt capacitance. So, result of the wide wires over a ground planes, limit speed of the circuit including the digital circuit. Typical significant for the low performance circuit are required to minimum place a capacitor from the voltage to the ground are used. Next is the inductive coupling there. So, transfer of the energy from the one circuit component to the another through the shared magnetic field. Change in the current flow through one device include current flow in the device. Next is the trace, one trace induced current in the another trace. Minimize the long parallel runs of the traces, run traces perpendicular to the each other. Next is the capacitive coupling, they transfer the energy in the electrical due to the capacitance between the circuit needs, minimizing long traces on adjacent layers will reduce the capacitive coupling. Ground planes are run between the signal that might affect the each other. So what are the steps in the PCB designing? What are the steps? First we take the film generation, then we take the shear raw material, then we drill holder, then we use the electroless copper, then we use the apply images on it, then strip and etching, solder mask, solder coat and silk screen. Then this is the steps we use in the designing of the PCB. Thank you very much.